Welcome students. Already in the previous video we have seen that joint equation of pair of line represents a homogeneous equation in degree 2. Now let us continue. Now under this theorem we have few remarks. So we will see the first remark. Now already we know that h square minus ab is greater than equal to 0 and b is not equal to 0. So the previous equations, as they are passing through the origin, we can write them as y is equal to slope into x, and second line again y is equal to m2 into x. Now referring the previous two equations, the first slope becomes m1 is equal to minus h minus root of h square minus ab upon b, and the second slope becomes minus h plus root of h square minus ab upon b. Now when you add these two slopes, the plus minus root of h square minus ab gets cancelled and you get sum of the slopes as minus 2h upon b. Similarly, if you take product of the two slopes, you will get a upon b. This you can try at home. You can see multiplying these two slopes and you will get a upon b. Now we have studied that if the quadratic equation in m whose roots are m1 and m2 is given by m square minus m1 plus m2 into m plus m1 into m2 is equal to 0. So this is a quadratic equation in m and whose roots are m1 and m2. So substituting the values of sum of the slopes and product of the slopes, the equation becomes bm square plus 2hm plus a is equal to 0. Now this equation is called as an auxiliary equation of your first equation, that is ax square plus 2hxy plus by square is equal to 0. So this equation gives you the two slopes of the lines passing through the origin. This you can utilize equation if you want to find the slopes of the lines. Now the next remarks are based on nature of the lines. Now if h square minus ab is greater than 0, then the lines represented by equation 1 are distinct lines. Similarly, if it is equal to 0, then they are coincident lines, that is one and the same line, and if it is less than 0, then the equation will not represent pair of lines. So these three are nature of lines depending upon the value of h square minus ab. And last remark is, if b is equal to 0, then we have seen that we get two equations of lines, x is equal to 0 and ax plus 2hy is equal to 0. So x is equal to 0 means you get one line as y-axis and the slope of the other line becomes minus a upon 2h. Now based on these theorems, we are going to solve few examples which are from your textbook exercise number 4.1. The first question asks that find the combined equation of pair of lines 2x plus y is equal to 0 and 3x minus y is equal to 0. So two lines are given. We know that product of the two lines will give you the combined equation. So combined equation is given by 2x plus y into 3x minus y is equal to 0. Multiply the two brackets and you will get the equation as 6x square plus xy minus y square is equal to 0. So this is your combined equation. Now move to the second sum. Find the separate equation of lines represented by 3y square plus 7xy is equal to 0. Now they have given you combined, we are supposed to find the separate equation. So take the given equation 3y square plus 7xy is equal to 0. From here we can take y common out. You get y into 3y plus 7x is equal to 0. So what are the separate equations? One is y is equal to 0 and other is 3y plus 7x is equal to 0. Now let us move to the next example. Find separate equation of lines represented by 3x square minus 10xy minus 8y square is equal to 0. Now here you can see the given equation is 3x square minus 10xy minus 8y square is equal to 0. Now in this example I am going to use the factorization method. So 3 into minus 8 is minus 24. So the factors are minus 12 and plus 2. So you can see I have written 3x square minus 12xy plus 2xy minus 8y square is equal to 0. First two terms take 3x common out. You get 3x into x minus 4y plus 2y common out into x minus 4y is equal to 0. So you have 3x plus 2y into x minus 4y is equal to 0. So the separate equations are 3x plus 2y is equal to 0 and x minus 4y is equal to 0. So if you have this type of example, here you can use the factorization method. Now in the next example, again you have to find the separate equation of lines represented by 5x square minus 9y square is equal to 0. Now 5x square minus 9y square can be written as root of 5x whole square minus 3y whole square. So here I can use the formula of a square minus b square. So a square minus b square, so this will become root 5x minus 3y into root 5x plus 3y is equal to 0. So the separate equations are root 5x minus 3y is equal to 0 and root 5x plus 3y is equal to 0. So here you can see I have taken different type of examples. If middle term is missing, then you can use the formula of a square minus b square. If middle term, all the three terms are there in the homogeneous equation, you can try for factorization method. And if one of the term, either first term or the last term is missing, you can solve by taking common. Now we'll move to the next example. Here we can see find k if the sum of the slopes of the lines represented by x square plus kxy minus 3y square is equal to 0 is twice its product. Now see the solution. What we are going to do is, given equation we'll compare with the general equation ax square plus 2hxy plus by square. So we get a is equal to 1, 2h is equal to k and b is equal to minus 3. We have already studied sum of the slopes is equal to minus 2h upon b. So here we get minus k upon minus 3, that is k by 3, and product of the slopes is a upon b, so it is equal to minus 1 by 3. So according to the given condition, sum of the slopes equal to twice the product, hence we get k upon 3 equal to minus 2 by 3, hence the value of k is equal to minus 2. Now moving to the next example, find the condition that the line 4x plus 5y is equal to 0 coincides with one of the lines represented by ax square plus 2hxy plus by square is equal to 0. So already we know the corresponding auxiliary equation is bm square plus 2hm plus a is equal to 0. As the line 4x plus 5y is equal to 0 coincides with one of the lines given by ax square plus 2hxy plus by square is equal to 0, its slope is minus 4 by 5 will be the root of the auxiliary equation. So minus 4 by 5 is root of bm square plus 2hm plus a is equal to 0. Substitute minus 4 by 5 in the given equation. So you get 16b upon 25 minus 8h upon 5 plus a is equal to 0. So clearly the LCM will be 25. So your answer will become 16b minus 40h plus 25a is equal to 0. So this is your required condition. Now next example, find the combined equation of pair of lines passing through the origin and perpendicular to the lines represented by 5x square minus 8xy plus 3y square is equal to 0. So let us start with the solution. So let m1 and m2 be the slopes of the lines represented by the given equation. Now comparing the given equation with general equation ax square plus 2hxy plus by square is equal to 0, we get a is 5, 2h is minus 8, b is 3. We know the sum of the slopes is minus 2h upon b, so we get 8 by 3 and product is a upon b, therefore we get 5 by 3. Now since what lines we require, they are perpendicular to the given lines. So we know that the product of the slopes of perpendicular lines is equal to minus 1. Therefore, the slopes of our required line will be minus 1 upon m1 and minus 1 upon m2. Equation of required lines will be y is equal to minus 1 upon m1x and y is equal to minus 1 upon m2x since the lines passes through the origin. So what are the equations? X plus y m1 is equal to 0 and x plus y m2 is equal to 0. So if we know the two equations of lines, we know that the combined equation is product of the two equations. So we can see that combined equation is x plus y m1 into x plus y m2 is equal to 0. Multiplying these two brackets, you get x square plus m1 plus m2 into xy plus m1 into m2 y square. So we know the values of m1 plus m2 is 8 upon 3 and m1 m2 is 5 upon 3. Therefore, we get the equation as 3x square plus 8xy plus 5y square is equal to 0. This is your combined equation of lines perpendicular to the given lines and passing through the origin.